Hello everyone and welcome to our webinar hosted by Testbirds and Magna Telemotive. My name is Kay and I'm the product manager at Magna Telemotive at the Division of Software Solutions. My co-host today is Richard Waldner and he's the head of partner management at Testbirds. Today we would like to introduce you to our VModel 2.0, which is a holistic customer-centric approach to software testing. But what does that actually mean? Well, let's take a car as an example. The link between the historically mechanical car and the present-day prominence of software is stronger and more important than ever before. A new car today is pretty much guaranteed to have some type of software integrated somewhere in both clearly distinguishable as well as out-of-sight forms. As the complexity of this software increases, so do the requirements and quality standards. In this webinar, we'll discuss using the VModel approach with validation and system functions. And what is a TTA framework? We will show you a practical example of test automation within the VModel. And why is test automation so complementary with Crowdtesting? We'll discuss this as well, and we'll show you some insights in combining the VModel with Crowdtesting. After our keynote speeches, we will show you the combined approach adapted to your needs with a panel discussion. So we will show you what actually the VModel 2.0 is. I told you before it's a new approach, and Testbirds and Magna Telemotive will show you why. Furthermore, we will show you or explain to you what the test automation with TTA actually is, and afterwards we will go into Crowdtesting, because customer centricity is the key. And at the end, we will have the panel discussion with all our keynote speakers, and we will ask them some questions. If you have some questions, always write them into the chat, and we will discuss them as well. First of all, let me introduce you to our keynote speakers, who are Georg Hansbauer. He's the CTO and Managing Director of Testbirds. We have Max Kirscher-Cameron as well. He's the head of sales from Testbirds. Unfortunately, he could not make it today to the webinar. From the Magna Telemotive side, we have Alexander Mosen, who is the Business Development Manager within Software Solutions. And last but not least, we have Bastian Reimann. He's the group leader of the whole division of Software Solutions. Now, I'll hand over to Georg.
Yeah, thank you very much, Kay. So basically, I want to start with a short introduction on the VModel. So what you can actually see here is basically a very, let's say, yeah, the model is very much like you would expect it to be. So I guess a lot of participants in this webinar already have seen this VModel. So basically is a combination of, or let's say a deep, how do you say, like integration between the actual software development process and also all the different software quality assurance artifacts. And what we are basically doing here from, let's say, a Testbirds point of view is, or where we see the value which comes from Crowdtesting, which we also will explain a little bit more in detail afterwards, is basically in the, let's say, in the early stages. From our point of view, it's important to take care of the user experience. So basically to see that you very early in the process can already incorporate user feedback, for example, in the system design phase. So basically what we as Testbirds are saying in the VModel is in early stages, we can try to incorporate user feedback into the different phases, and later on in the different also when it comes to basically building the system, integrating it, that we can do the functional part, which you also can see on the right hand side. You can see different services which we offer from a pure, let's say, Testbirds point of view. So before we show the combined approach, so early on in the development process, in that case in the VModel, do some usability, user experience studies, like evaluating prototypes in the early phase, and then afterwards going into the functional testing perspective, and also doing crowd testing, for example, what we call end-to-end testing, which is a little bit different than what you would in traditional software Q&A understand under end-to-end testing. But also we will talk about that later on in the webinar, what we actually understand under end-to-end testing and why actually crowd testing is providing a great value in that, let's say, late stage of the software development cycle there. And then I hand over for the Magna point of view on the VModel and software testing.
I'll continue now. As you can see here, the test pyramid from Mike Cohn, from the book Out of Succeeding with Agile from 2009. It is a model to structure your tests, especially your software tests, and especially automated software tests. So in an agile way of software development, you try to do a continuous integration platform, or maybe a continuous delivery method. So on the basis here, the smallest test you can do are unit tests. These are the smallest tests you can do. And you will have in a software project, most of them are unit tests. You can very quickly develop them. They are isolated on the system, maybe on a server or something else. And it's necessary for the continuous integration process. Further on, you go to the next layer. Then it's a service or API layer. Now you try to build some tests that checks the modules, the software modules, also how they're functioning together. You want to ensure that the modules work properly together. That's the approach here. And for sure, in between, you can define tests on yourselves, define categories on yourself, which is needed in a project. And the last layer, here the UI tests, these are end-to-end tests, tests that the user can see, that the user can feel. And these are integrated tests, they're non-isolated. As you can see on the y-axis, the more you go up to VModel, the more you need to develop those tests, and the more the complexity there are. The execution time also increase, and the time to develop is more complex than the unit tests. So this is a way how to structure unit testing, service layer testing, and UI testing, just only in an automated fashion. What we find out together with our colleagues at Testbirds, if we could combine both ideas of the VModel and the automation pyramid, we find out that both companies fit perfectly together. That means we can use all advantages from Testbirds, and on top we combine them with the automation pyramid. As you can see on the pyramid above, you can see the crowd testing stuff. So that means all tests you're not able to automate, or if you need some feedback from the user experiences, we can do this with the crowd testing approach. So maybe Georg will add some other comments on this.
Yeah, thank you very much. I mean, from our point of view, basically crowd testing can be a very great addition to the, let's say, software testing aspects, and especially to the automated aspects, because it adds this kind of, let's call it, reality random layer, where we have the possibility to also be sure that our software products meets the quality standards, that we actually do tests outside the normal perspective of the development team and the test team, and basically add this kind of, let's say, randomness factor into it. But nonetheless, of course, all the tests we need there, also from the unit tests, API tests, etc., are very important to have a stable software product and being able to basically make quick deployments and quick builds. Yeah.
Oh, hello everyone from my side. My name is Alexander Mosen. I'm a business development manager at Magna Telemotive, and I'm about to tell you something about Magna Telemotive. What is our company? What are we doing? And of course, we want to come back to this VModel 2.0 later. And at first, it's time to give you maybe a short overview about test automation and what test automation can add to our VModel 2.0. Okay, so first, a little company introduction, so you get to know the company Magna Telemotive and what we are doing. We have locations in 4 offices in Germany, which are Mühlhausen and Tele, as still the main office where the founders were coming from. Munich, Ingolstadt, and Wolfsburg, close to the OEMs, of course. And we were founded in June 2000. Now we have around 670 employees. And we are a part of the organization Magna Steyr Engineering, which contains an overall of 3,500 employees. We have several engineering locations all around the globe, as you can see here in Europe and Asia. And also the total company of Magna, or the whole Magna group, in the meantime has more than 175,000 employees. So we are really a very big company overall. Yes, you can see it here on those last 2 ones. Those are the competencies and services that we offer here at Magna Telemotive. We are basically an engineering service provider with expertises in the field bus systems and infotainment, where our company really grew in the beginning strongly, especially in the BMW field. But also we adapted to more fields of expertise like connectivity, driver assistance systems, also, for example, developing LiDAR systems or camera systems. We have vehicle diagnostics knowledge, electromagnetic connectivity, and electromobility. So those fields of expertise here on the left side are the fields where we are coming from and where we have the competency in engineering. But we also provide the services on the right side accordingly, like offering you a project management, technology consulting for the projects, hardware development projects, or system integration or test houses. And today we want to take a look at HMI testing, which is the focus of this presentation. And of course, our company does more than that, but we want to get more into detail with this topic today. So that's why we brought some example HMI here. This is an instrument cluster, which is, so to say, a demo instrument cluster. It's not built into any car right now, so this is for demonstration purposes. And you see a lot of information on this instrument cluster. And this instrument cluster has to be validated that, of course, if, for example, you send CAN messages or Ethernet messages to the ECU that builds this HMI, you want to check if the right symbols are coming up, if the right information are showing up. And for example, here on the bottom left corner, there's traffic signs, or on the right side, there's the location München, which means Munich, on Wednesday, the 8th of May, 2019. And those are all information that are sent into an ECU, an automotive ECU in this case. And we want to check just from the image that we have here if the information is displayed correctly. And there are several algorithms that you can use for this. What we often use is frame grabbers to capture the images and then do some icon search on this image. For example, to search this traffic sign here on the bottom left side, or do some video sequence analysis where you take a video of a part of this HMI for some seconds and see if something pops up, or also optical character recognition to recognize those words in the image, as we have here with the location and the date. So those are basically the algorithms that are used to test an HMI. And now we want to give this whole automation system that we show a broader picture on the next slide, which shows you in the middle the test PC, where we have some software installed. In our case, it's the TTA framework. This is a Python test automation system, really open one that can be used for different purposes. In this example here, we do some HMI testing. And starting from the HMI, we explained in the slide before, you have here on the right side the target. The target is the HMI or maybe the ECU that on which the HMI is running. And this is the device under test that we want to test. On top, we have an environmental simulation. In automotive, that's often a REST-bus simulation, for example, which can be done also with other tools like famous CanoE or something like this. On the bottom, we have additional test software that might be used, like OEM-specific diagnostic tools or flashing tools. And there's also a hardware setup with hardware-in-a-loop benches, cables. Of course, you want to send some information to the target or send some bus signals to the target. And this right side of the picture can be combined in a continuous integration environment. That means with every new build, the tests are running automatically. In general, you see only blue lines here or dark green lines in this picture. Those are all automated connections. That means we have a fully automated system here, and that's also what we want to achieve with you or with our customers, that we have no more manual tests or manual connections if not needed. Of course, that's sometimes it's not possible to do everything in an automated fashion, but our goal is to automate as much as possible, and as many connections you can automate, the better. Here on the bottom of the slide, you see a test case repository, which might, for example, be a Git system. And in this test case repository, you have different test cases. The blue ones, those are Python scripts written in TTA, which is the native Python framework. And also connected to this whole test automation channels on the left side, the test management tools or PLM system, where you have requirements, reports, defects, or also a project management board maybe. And to make a little bit more clear how this whole automated system works, we can give an example. Here, an automated, the process that we want to show is the automated test case generation. So from the requirements, we do not want to use an engineer to program the test case, but we want to generate this in an automated fashion. And thereby the TTA pulls the requirement from the requirements database, and an automated test case will be generated automatically. So that, of course, takes some implementations until this works, and you need to write the requirements in a certain form. But we have several customer projects where this is already working. And what the automated system, of course, does is to synchronize the test case with the test case repository, so that always the newest version of the test case is in the repository and is stored and is accessible by all the developers. Next, of course, now we have generated a test case, but the most important thing about test automation is, of course, the execution of the test case. Now we see the test case execution. The test case is loaded into the TTA, and now the information is spread in a way that the target gets the information. For example, the REST-bus simulation starts running, the flashing tool starts flashing the target automatically, and later some Ethernet messages are sent. And the orange lines that are already displayed, and maybe if you click again, the other ones are also displayed, lead the information on the way that it should go to the target. Now we could see that the target has moved shortly. That means the information got its way to the target, and maybe we have sent an Ethernet message that says the car has accelerated until 200 kilometers per hour, and now we want to check if it's 200 kilometers per hour on the HMI. Now, after this is done, we of course get the information back from our algorithms that are running. And now with the green lines that are showing here, the information is flowing back to the TTA system. And now we get a result. The results are summarized in a report. As you can see here, report generation. You can see that the report is also, of course, automatically generated. How else could it be? We have a fully automated system, of course. The report is synchronized to the report database, as you can see. And what might have also happened is that the TTA found some defect that it wants to give to the developing department. As we already said in the VModel, the developing department gets the feedback from the testers. And this might be such a defect ticket that we have here, the red one. It's generated now here, and also synchronized to the defect management database. And now the development department gets a feedback. Okay, we had 100 test cases, 3 of them were failed, and this is the results. So what we have now seen is a fully automated system for HMI testing. And of course, this is really helpful, and this is our core competency here at Magna Automotive, to fully automate your testing. But we want to hand over now again to the Testbirds, who have an approach that comes into game when test automation does not make so much sense anymore, when you have questions like, does this HMI look good? Is it too bright? Is it not too bright? Something that an automation cannot really answer, and really some exploratory questions also. And yes, so I will give over to Georg again.
Thank you very much. I will pick up on the topic, and as it was just mentioned that nicely, basically give an idea how the, let's say, customer or the user can be also involved into the whole quality assurance part, and also basically how this can be done during, let's say, a VModel based software development approach. I also have a brief agenda here, so I also will show one slide about Testbirds, and then I will basically show how we can utilize, let's say, crowdsourcing to do this kind of manual testing efforts, and also talk a little bit about actually why it makes sense and why not everything can be automated. And then we also have a very hands-on case study from BMW Motorrad, which also gives a nice idea on basically how to also extend beyond the automation part, which was just shown by Magna, which is still, automation is still then a key pillar of everything, but it can also not do everything on the other hand. So basically Testbirds is a leading provider of crowdsourced software testing. We are around also now for already a couple of years, and our headquarters is here in Munich, and we also have 2 offices in London and Amsterdam. Then basically the next question is actually now, what's crowd testing? So, I mean, you all have already heard now the topic or the term a bit and there. And basically what crowd testing basically means is that we utilize crowdsourcing into the software testing processes. And what it basically means is that we try to evaluate how user-friendly a product is, or actually also how well the functionality in different countries, different regions, different continents, on different more or less exotic mobile, desktop, whatever devices is. That's where crowd testing basically can provide a valuable addition to software testing, and can also basically extend already existing automation efforts. So in our case, basically this crowd, which can be utilized for testing, is spanning around the whole globe. We have basically a little bit more than 400,000 people. And what's also really helpful about this crowd testing approach is that basically the crowd there is testing on their own devices. So for example, especially when it comes down to mobile devices, this is really helpful because you have access to almost 1 million devices in a lot of different countries, which can help you to test a lot of different variables. So basically, depending on the software development model you use, and I mean, of course, that's also the case for the VModel, where we always see crowd testing helpful is very early in the stage, basically to get user feedback, so about user experience, so UX. So that's what also was just mentioned, for example, how well is the HMI designed. So you can do this very early when you only have a concept or a prototype, and basically you still don't have a running software yet. Then when it comes later down in the software development process, we can do more functional testing. So we can add this random reality factor. We can test the software, for example, let's say connectivity from an head unit, a connected car or whatever, and can see if it also runs with exotic mobile devices. Or we can do that, what we call end-to-end testing. There is basically really taking out the user and seeing that the overall, let's say, user or customer experience end-to-end is working. So let's imagine there's a connected car app or something like that, and we really want to evaluate if it really works, and it not only works in the German headquarters where it was designed, but if it also works in China or in the United States or wherever, basically, with different kind of regional settings and whatnot. So what we also have here to basically show a little bit of a practical approach, to also show a little bit how this crowd testing methodology basically can be used to extend existing software testing approaches or also very sophisticated ones. We bring one case study here. And basically this case study is from BMW Motorrad, so BMW motorcycles. And also what you can see here on the right, you can see the whole scenario. So it's also more complex than you might imagine in the first place. So basically you have a motorcycle, and the motorcycle already has different kind of head units. And basically then there's a lot of connectivity features. There's a mobile app which is connected via Bluetooth. And then there might be also certain other equipment, like for example, helmets with certain hands-free systems. And a very valuable approach what we can do with crowd testing here, let's also say in the VModel at the end, is that what we call end-to-end testing. So it's really imagining the user and basically seeing if all that works. So, and basically one of the use cases really would be, we want to have BMW motorcycle drivers in different countries who are using the map guidance functions, because the head unit on the motorcycle actually doesn't have all the navigation parts, which for example a car would have, but it's running on the mobile device. And so you want to test it on different countries and different users, and you just want to have this random reality factor. You see all these challenges, and I think this also makes a good point where you can automate a lot, but not everything. So in that case here, we basically, let's say we want to be sure that the whole end-to-end experience works on two different smartphone platforms. So you have iOS and Android. Then you have a lot of different smartphone versions which are still considered major and need to be supported. And then you have some major models. And then you have different countries with different languages and different other regional limitations. And on the other hand, you also have the motorcycle. So really here with crowd testing, then we really recruit also a smaller BMW, let's say, private community who has the different motorcycles with the different head units and the different software versions which are running on them. And then we really want to basically end-to-end figure out if it all works. And again, here, crowd testing is then an addition to the existing software testing efforts. So besides all the internal tests, the automation and whatever, it's really gives another helpful basically way of figuring out if actually the software in your, let's say, complex scenario is working or not, and what kind of issues you bump into that. So again, I hope this helped and gave a nice overview on also where crowd testing fits into a software development approach.
Thank you very much for everyone tuning in. And yeah, I wish you a great evening and have a good time.